Hi, my name is Antonio Tamayo, and today I'm going to present the work of the team NLP-CIC-WFU at DisTEMIST shared task. The title of our work is Multilingual BERT and Simple Post-Processing, a baseline for disease mention detection in Spanish. I am presenting on behalf of my colleagues Diego Burgos and Alexander Gate. First of all, I want to say that we only participate in the name entity recognition task. This is the first task of the shared task of the competition. And the task we faced in this work required the participants to automatically identify disease mentions in a dataset of clinical cases in Spanish. Here in this table, we can see a dataset sample where we can see three disease mentions here: syndrome post-flevítico, sepsis grave, and HTA. This is an acronym. These three disease mentions are in the same file, file 1, and here in the column of 0, we can identify the first character of this disease mention in the text, and with the column of 1, we can identify the last character of this disease mention, and so on. Well, here with this picture, I'm going to describe our system. Our system consists of 4 stages. The first stage is a pre-processing stage. In this stage, we carry out a tokenization with SPICE. And then we carry out a tagging with the scheme, with the BioASQ scheme. This was carried out using a custom code in Python. Then, with the clinical cases representations, we use the whole text. That's very important for our system. And we used multilingual BERT as a backbone model to tackle the problem as a token classification problem. For the second and the third stage, we used the transformers library from Hugging Face. Well, for the transfer learning process, we changed the prediction head of the backbone, the multilingual BERT model, to tackle the problem as a token classification using begin inside and outside labels. Here we can see the hyperparameters that we use in our work, and highlighted we can see that the best configuration was for the learning rate 5 powered by -5, and for the epoch we used 7, the value of 7 epoch. We used for all of our experiments 5 iterations, and we used the 75% of the samples for training and the 25% of the samples for validation. Then, with the entities extracted by our model, we applied a simple post-processing. We concatenate all the subwords. We concatenate all the contiguous entities extracted by our model. We applied orthographic and grammatical rules, and finally we decode the output from the BioASQ scheme to the output required by the shared task, by the competition. For the post-processing, we use custom code in Python too. Here in this table, we can see the simple rules that we apply in our post-processing stage. If the predicted disease mention concurs with non-content words or punctuation marks, then leave out the entities detected. If the predicted disease mention ends with non-content words or punctuation marks, delete the match and fix the off one. If the predicted disease mention contains a mark of a new line, replace the match with a space. And finally, if the predicted disease mention contains a space before and or after a hyphen or a parenthesis, delete the spaces or the space and fix the off one. Here in this table, we can see the results that we achieved with our system for the training and testing partitions. We can see that we achieved a micro F1 of 0.5 0.54. Here in this table, we can see the error analysis for our system. We define the truncated error, extended error, and missed error. And here in the left column of the table, we can see the gold standard, and in the right column of the table, we can see the model's prediction. Here, with the labels, we can identify what type of error we have here. Then continue with the error analysis. In some experiments carried out after the competitions, and we confirmed that passing the whole clinical case to the BERT-based model in the inference phase causes low recall. Using a paragraph or sentence strategy to pass the texts for inference considerably improves the recall measure. Here we can see that our recall is very low. So in this slide, we can see that passing the full clinical text as input to our model, we can see that there are entities that the model does not identify. But if we pass a shorter input to the model, we can see that there are new entities detected. And additionally, here we throw this question: are there missing entities in the training and testing dataset? Why? Because we can see here that our model detects these entities and they are not tagged in the training and the testing dataset. Well, the conclusions of our works are: our system can be considered as a baseline for disease mention, detection, or identification in a corpus of clinical cases in Spanish, because our system is based on the transfer learning technique using multilingual BERT plus simple post-processing without any external resources, and it achieved a micro F1 of 0.54. The text length is an important aspect for the inference with BERT-based model. This is the cause of the low recall. And perhaps new experiments with different pre-trained language models can achieve better performance for this task. And finally, despite the micro F1 achieved, our qualitative analysis suggests that the model performs well to identify disease mentioned, and it can be used as a starting point for an information extraction system in the medical field. Well, here we have the resources to replicate our work in this GitHub repository. And if you have any question, do not hesitate to contact us. Here you have our email addresses, and here you have the references of this presentation. That's all. Thank you so much.